Hello, class. So make sure that you open up the third file, download it into your computer, and then upload it into your Colab so you can start following with me in the video. Okay. So what we're gonna do right now, we're gonna talk about some NumPy operations. Again, like I said before, the advantage of NumPy is that it turns uh, data structures into this efficient array that allows you to make different operations really fast. It makes it not only operations but find different values like standard deviation and mean value and stuff like that. So it makes it really efficient. It makes it really quick. That's the advantage, is quickness. And especially when you're dealing with a lot of data, efficiency, speed is really important. Okay. And also storage makes it really it makes it into a smaller size file, right? When you actually when it stores that information, it makes it into a smaller size that allows you to be able to move, to be able to process that information really fast. If you have taken the structure, you will remember that that is very important. Okay, so let's start with the arithmetic part. And so we'll start with the uploading, right, or import numpy as np, and then r equals np.arrange. Again, we're importing the library numpy and we're calling it np, so that way anytime we want to access anything from the np, we can just use from the numpy, we can just say np. And we're gonna create this array object using the arrange from 0 to 10. So that means it's gonna start at 0 and it's going to end at 9. So we're gonna create this array that is gonna be starting at 0 and it's gonna go all the way to 9. If I run this, right, we wanna make sure it runs first. And now that it's the check mark there, we're gonna move on to the next one. And what I'm gonna do is I'm gonna add my two arrays. And you're gonna be able to see that I can use this operation of addition. That makes it really easy to add different arrays. And you can see now I have added that. But if you want to see it, let me just show you R, right? So that way you can see that I have this array from 0 to 9. And if I click array plus array, it's just gonna add the arrays in order, right? 0 with 0, 1 with 1, 2 with 2, 3 with 3, 4 with 4, 5 with 5, and so on. So it adds the elements based on their location on the index. And I can actually multiply them as well. I can multiply arrays. So if I multiply them, again, it's going to multiply the 0 with the 0, the 1 with the 1, the 2 with the 2, the 3 with the 3, the 4 with the 4, and so on and so on. I can also subtract them, which makes them, again, really convenient. And that gives us 0 because you're subtracting 0 with 0, 1 minus 1, 2 minus 2, and so on and so on. And we can divide, right? But of course, if we divide by 0, that's going to give us it should give us some invalid division, right? We cannot, you can see everything else is good except the first one because that's not defined, right? 0 by 0 divided by 0 is undefined. It's technically a infinitive value. Is it infinity? Yeah, that's the question, right? We don't know what the value is, so I'm not gonna say what it is. If we would have 1 divided by 0, then that's actually infinity, but 0 divided by 0, well, we don't know. And so we can do 1 divided by our array, and you can see that the first one is infinity, right? Like I said before, 1 divided by 0 is infinity, so you would get that infinity. 1 divided by 1 is just 1, and then you have 1 divided by 2 is 0.5, 1 divided by 3 is 0.33, and so on and so on and so on. So you can see that it computes all these values. This is the advantage of using NumPy. It gives you these operations that are really fast. And you don't have to do any loop. It's already set up for you. And we can do power of 3 we want to. And you can see every number is being raised to the power of 3, 0 to the power of 3 is 0, 1 to the power of 3 is 0, 2 to the power, sorry, is 1, 2 to the power of 3 is 8, 2 to the power of 3 is 8, 3 to the power of 3 is 27, 4 to the power of 3 is 64, 5 to the power of 3 is 125, and so on and so on. Now, there's some other universal functions for the arrays that are important to talk about. For example, the square root. And the square root of the array, we can figure it out by doing the NP, which is the library, and then the square root is the function, and we're going to submit our array. So we can press enter, and then we can just have this array that has taken the square root of every single number. We can take the exponential value of every single number, right, by doing NP exponential of my array. And so now we're taking the exponential value of, so it will be the exponential number of 0, the exponential number of 1, the exponential number of 2, and the exponential number of 3, and so on and so on. Remember, the exponential number 1, e to the 0 is 1, e to the 1 is 2.7, that's the actual value, it's an irrational number, and so on and so on. We can find the maximum value of our array if we want to by using NP array, max array, and that's going to give us our 9. We can find the sign value of every single number. So this is actually pretty cool because you can actually have your list of numbers, and you can actually calculate those numbers instantly by having an array. So that's why it's very, very convenient to turn your values into an array, just because you can actually apply all these log values, these mathematical values into your array without slowing down your computer. And of course, right, the log of 0 will be negative infinity, right? If the function is going to negative to 0, and then the log of 1 is 0, and then the log of 2 is 0.69, and so on and so on. Right? So and that's it. So that's some of the other operations that we have, universal operations that we have for arrays. Okay, of course we didn't talk about all of them, but I just wanted you guys to have an idea of the power of the Numpy, is to be able to deal with a one-dimensional array and two-dimensional arrays. Okay, just mainly arrays, just values, numbers, and we can actually multiply them, add them, apply a lot of the linear algebra properties that we need, and we can actually find a lot of things with it. So there's a lot of properties that we didn't talk about, but just to give you an idea of what this is doing. Okay, and this is the end of this one. So once you're done with this, make sure you click save, right, and then you're gonna file, print, right, and you're gonna save it as a PDF, right? So that way you can submit this one.